So setup, that's the one big function you should look at. Draw is the one that runs every frame. This is the one that does all the actual work. There's things in there, it clears the background. You can set things like how thick lines are, what color the lines are, and then you can draw a line. So this is the simplest possible thing. This clears the background, sets the stroke weight to 2 pixels, sets a color, and then draws a line. It's boring. The examples in the workshop content are much more interesting than that. These are all that are really necessary, but if you want to have any kind of interactivity and live control over your sketch, you should have the key pressed function in there. And this gets a key, it actually works off the key global variable, which is a bit of a hack. But you can see just this idiom of having a case statement. And then you can control the thing live. Most of the examples have some kind of control built into them, so you can just see the code there, and you can play with that. So those are the absolute basics of processing. When you're running it, and I know that people with laptops have all been able to successfully run these things so far, you just hit play or Control R, and that executes it. You know what you got here. Control Shift R will do that in full screen, which is more interesting. Okay, so I can walk through the FFT example now, really quickly. And for people who came in late, we'll get just the format of the workshop is that every hour is 20 minutes of theory and 10 minutes of code walkthrough, and then half an hour of hacking and questions and stuff. So it's a completely open format like that. And the first little session was getting processing installed. That's a really quick process, so we can catch everyone up if they're interested in stuff. This isn't just me talking for 4 hours. That would be only awesome for me. Okay, so I'll try to make this a little bit more visible.
So, out of curiosity, why do you use FFT instead of fractional octave?
Okay, so the question was, why do I use the FFT instead of fractional?
A fractional octave, like a recursive filter? Or...
Okay, the simple answer to that is because I like the FFT and it's easy to get. There are libraries built into pretty much every audio processing system that will give you the FFT. And yeah, if you had stuff, so I guess with fractional octaves, you'd get actual notes. Like, so it'd be more musical that way, yeah. That would be better, because if you had the actual notes, because then you'd know, hey, this is C. Or you'd know, hey, we just switched into a minor chord. Let's change the color palette to bluish. You know, that's something that from an FFT is a hard thing to detect. And so that would be good. The answer is simply because I haven't gotten there yet. If that's an easy thing to write, or it's an easy conversion from the FFT, I would love to sit down with you and write that. Awesome, and we'll do that later, okay. Also because your BFF, the FFT, I love that as a title. Okay, so we're going to walk through this code. This is just going to take 5 minutes. And then we'll get to the hacking part and we'll catch one up. So now I can show off my laser. Okay, so if you can open up the mic input. Oh, this is the wrong example. Sorry. Okay, I'm going to do the mic input ESS. There's a mic input minim example. The difference between those two is that minim is the sound library that's built into processing, but don't use it. The FFT output from it is crap. The ESS library, which the Sky Krister made, is much better. And if you run the two and you put the same sounds to them, you'll see that. The minim, I can just run it. I can just prove it. So you can see that the ESS FFT, it's sort of even. And everything that you're doing, like all of your levels are kind of the same height. Now, if you use the minim example, if you compare the minim example, will this run? Okay, yeah. Let me just run this to full screen. Okay, so you can see that with the minim example, and I gotta be a little quieter. So the bass levels are way higher, and then you have this power frequency, this black body radiation curve going here. So minim doesn't normalize its sound, its FFT levels. This is what makes it sort of crap for us, because we don't want to. We're going to have to normalize that later. We're going to have to say, oh well, treat these as less significant. If you're turning these into the size of objects or the brightness of colors or something, or the length of lines, this is really crap to work with. It's really hard to do. So everyone just look at the ESS example. Other than that, all the code is exactly the same. Okay, my comments are awesome. FFT stuff is at the top. You got to import the library. FFT-based things. So we've got a couple of variables. These are not really super necessary, but that's what I do. Just a couple of floating point variables. I'm assuming that the whole audience is comfortable with code. Here, I didn't get to survey all of you. Okay, so I'll just run through that. Audio tuning. We've got when you convert audio samples to an FFT, there's concepts like the window, the length of time that you're looking at to generate the sound. So that's controlled with the buffer size. The minimum and maximum limits of how loud the sound is you want to look at, and the damping. How quickly the FFT bars should fall back down if they've been pushed up. So that's what these are. You don't have to worry about these right now. They're not interesting to play with. And then just the FFT, my FFT, and the audio input objects. These are just the ways that we access the FFT library. Also not really worth playing with. So we've got the setup function in here. You can see I'm just size, frame rate, and then I set up my audio in the setup ESS. You can see a trick I'm doing here where I'm setting the size to screen width and screen height. The reason I do this is not to annoy you and push everything off to the bottom right off of your screen when you run. The reason for this is that every single projector has a different fucking resolution. And that will kill you when you're at a live gig and you are suddenly having to rewrite all of your code and change all of your resolution variables. If you just do screen width and screen height, you're done. You just run full screen and it looks good. So always do that. We'll go through this. Setting up the ESS library. This is kind of uninteresting stuff. You don't have to worry about this right now. These sort of things aren't necessary to know, but just to run through it really quick, we tell the library to start itself up. We tell it how big of a buffer to look at. We initialize the FFT object, and we set our normalization and damping on the FFT. Those are those global variables you saw before we started. Okay, so then the draw function, I clear the background, and if you don't clear the background, you'll have the old background contents, and it'll look like junk. I set the stroke color. I'm going to deviate just for a second here and show you the color selector. So if you're really terrible at knowing what a hex triplet looks like, you just use the color selector. Pick nice colors with this. That's one of the nice things in here. Okay, so then we'll just bounce back to what this thing looks like for a second. So you can see that we've got blue lines along the bottom for each frequency bin. And then we've got these white dots that sort of get larger when there's energy, and then they fall back down and they get smaller. So the way we draw that is we take the FFT spectrum, and our index variable here is bin. Take the FFT spectrum, we put that in a bars array. We take the difference between the previous previous frame of where the dots were and the spectrum. So this is how much they've moved in the last frame. We get that diff, and then we move them. This is just some simple damping code. This is a simple little control system. We move them towards where they should be. So basically, if last frame, the frequency was this loud, and now it's this loud, we don't move that white dot there immediately. We slowly move it towards there. We take this damping function. So that's how we get this sort of slow fall off, where the things, they get a value and then they slowly come back down.